All right, this is just a continuation of the last problem. Sorry about that. I ran out of time. This thing that I'm using to record these, it only gives me 15 minutes at a time. So, anyhow, that's the free version. So that's kind of why I use it. All right. So anyhow, if I wanted to pay, someday I should look up and see how much it is. Anyhow, so 15 minutes at a time. I wasn't paying attention to how much time. All right. Anyhow, let's finish this problem. So we got 2,214.5 arc seconds. So we convert arc seconds to arc minutes, and then we know that, of course, come on, there it is. We know that 1 degree. That's a little circle. 1 degree is, of course, 60 arc second. Sorry, arc minutes. 60 arc minutes. All right. So let's get our calculator out. All right, we'll clear this. All right, so, oh yeah, and I guess I should close the parentheses right there, just to be technically correct. All right, so here we go. So 2,214.5. All right, and so we divide by 60, divide by 60 again. Another way of saying that is divide by 60 squared. That's literally it, right? And so that's the number of degrees in 2,214.5. So let's see. So again, what I would do on the test is tell you how, let's say round this to, we'll do it this way. How about we'll round it to 2 places past the decimal, all right? So look at that answer and think about 2 places past the decimal, right? So that would be 0.62. Does everybody see that? So it's 0.62 because what's the next digit past the 1 is 5 or greater, and so you round up. So the answer turns out to be for this one for theta 2 is 0. So this is what you put in the calculator, 0.62. If it said, to round, now of course it's degrees, but it says to put it in degrees. So any of these, any of the ones on Blackboard where it's a numerical calculation, you don't put the units, right? It's just like the lab quizzes. You don't put the units. It asks you what units it should be in, and then part of what you're doing is you're you're coming up with what the proper units are. All right, so that's the answer. 2 places past the decimal. All right, so properly rounded. All right, let's do the next problem. All right, so here's the next problem. Hold on, I don't know that you can see that. Hold on. All right, so this is Kepler's third law, this problem right here. So this is the next one. It says an object is found to be orbiting the sun. Okay, so that's really important. The fact that it's orbiting the sun allows us to use this equation. Okay, so it goes like this. So oops, I forgot to switch. So A cubed, and A has to be, that's called the semi-major axis, is equal to the period squared. All right, so that's always true if it's an object that's orbiting something that has the same mass as our sun. By the way, that's why in our project, part 1, we used an example where our 3 planets, the 3 planets that you used, were orbiting a star exactly the same as the sun, which wasn't really true, but it allows us to use this simpler form called Kepler's third law. All right, anyhow, so the period, and this particular one says, all right, if you know what P is, all right, so this is what P is right here. So P is, I guess I should indicate this. All right, so in this equation, so this is the one that Kepler wrote, almost 400 years ago. P has to be in years, which it is, and then A, which called the semi-major axis, it has to be in units of AU, which are called astronomical units. Right? We kind of talked about that before. So if you wanted to convert AU to some convenient unit, 1 AU, I mean, we're not doing that here, we're just finding the answer in AUs, but the conversion goes like this: 1 AU. Let's say you wanted that's supposed to be a U. It looks more like a V. Anyhow, if let's say you wanted to convert it to kilometers, for example, it turns out to be 1 AU. The distance between the Earth and the Sun, that's the average distance between the Earth and the Sun, is approximately 1.5 times 10 to the 8th kilometers. So I'll write it like we would do it in Blackboard: E8 kilometers. Right. So that's remember, in Blackboard, you don't write the units, all right, in these problems. All right. So anyhow, let's do this problem. So A, the semi-major axis. So you have an A cubed. So you have to take the cube root. All right. So the cube root of p squared, which in this case is 1. Here, so I'll put this in parentheses. 167.9. All right, and of course you have to square that. All right, so this is different than what we did in the project. Right, in the project we were given A and we solved for P. Right, this case we're given P and we solve for R. Anyhow, that's and on the test you could be you'd be given one, find the other. Right. And so just to let you know, the way that you do that, of course, would be that P, right, that, in this equation up here, P would equal the square root of A cubed. All right. And that's in fact what you did in the project. All right. All right. So what is this equal? All right. So let's get our calculator. And so this is what A is going to be. So just keep in mind, like for example, if the period was 1, right, 1 squared is still 1. The cube root of 1 is still 1, and so that's for the Earth, right? The Earth is 1 astronomical unit away from the Sun, and it takes 1 year to go around the Sun, right? Like Mars it takes about a little more than 1.5 years and so forth. So anyhow, let's see. This calculate. So let me see. One thing that you have to know is to do the cube root. All right, that's raising something to the 1/3. So some calculators, like the Texas Instrument calculators, has a cube root. Your calculator might. This one doesn't have a cube root, but we can take the cube root. Let's do an example, for example. Remember what the cube root is, right? So if I take 2 raised to the 3rd power, that of course is 8, right? So here, this is just an example that I'm doing before we do this problem. So if I take 8 so raising 8, so this is my little example here. So the cube root of 8 is also known as 8 to the 1/3 power. That's another way of writing the same thing. All right. So we already know, since 2 raised to the 3rd power is 8, the cube root of 8 should the cube root of 8 should be 2. All right. So let's see that in action with our calculator. So I see here. Let me start again. Sorry, start again. All right. So 8 raised to the now you got to be careful here, okay? Because if I raised it to the 1 divided by 3, I'm not going to get the right answer, right? It gives you like an approximation. All right. So don't do that. So this is the proper way to do it. All right. So it's 8 raised to the, and again, it's 1/3. So to be exactly 1/3, you have to use parentheses. So parentheses 1 divided by 3, close parentheses. All right, and then that will be exact. And so when I hit equals, it should give me a 2, and it does. All right, so now all I have to do to do this problem. So we're back to our problem. Not we're still doing a cube root, but it's got to be the cube root 167.9 squared. All right, so here we go. So 169 is, sorry, oops, I messed that up. It's 167. So it's 167.9. So I square that, and then I raise that to the power. So again, if you have a cube root button, use the cube root button. For example, I know if I wish this was a Texas Instrument, you hit the math button, and I think it's the third or fourth option gives you the cube root. Anyhow, so we're taking that, we're raising it to the, again, we have to use parentheses, 1/3, close parentheses. And so this is going to be the cube root, and that'll tell us how far away this is. Right. So this is 30. So this is actually Neptune, by the way. Let me think. Is this Neptune? This is even actually, I think this is Uranus, the planet Uranus. Anyhow, I mean, you could look up and see what the period is. And so this one turns out. Let's say we rounded it to one place past the decimal. So that would be 30.4 years. Okay, so 30.4 would be this is what you'd enter into Blackboard. All right, very nice. So let's do another problem. All right, here's the next problem, very similar to what we've done before. So when I do this kind of thing in a review, you might expect that you're going to use this formula more than once. Okay, so all right. Anyhow, it says at what distance? All right, so we're looking for D in this equation. Is what's the distance of an object if the parallax? Okay, so P, as measured from either end is so they basically give us what the parallax is. So that's I'm sorry. This is the base, and then this. So the base is 914.7. So that's what the B is, and then the parallax is 7,988.1. Of course, it's in arc seconds, right? It's given to us in arc seconds, so that's why I put the 2 hash marks. But remember, just like we did in the last 2 problems, to convert arc seconds to degrees is really simple. You just divide by 60 squared, all right, and you'll get an answer in degrees. All right, so let's do that real quickly before I run out of time. Let's see. All right. I mean, if I run out of time, I'll just use the next, so 709.88. Let's see, is that the right number? 988.1. All right, divided by 60 squared. All right. And, look at the problems. These things it's completely worked out for you. Of course, you're going to have different numbers. So, just kind of follow along. All right, so I'm going to round this to, let's say, 3 places past the decimal. All right, so the base here, so 3 places past the decimal would be 2. So here, it would be 2.219, right? Because that would be 3 places past the decimal. So here's my calculation. Right, so it's 180 divided by pi. And then times our baseline, so here, times the baseline, which is 914.7. Of course, that's kilometers, and so the distance will come out in kilometers. And then, I've already forgot, what was it? Here, I'll just, let me pause this and then write it on here. All right, so there it is, rounded 3 places past the decimal. So let's take a look at that. There's the calculator, 2.219. All right. So anyhow, let's do this problem. Let's see. So here. All right. So I've already put all this in my calculator. Remember, it's the 180 times the distance, and then in parentheses divide by pi, and then the 2.219. And so this is what you get, right? There it is. Let's say it was rounded to 1 place past the decimal, since that's a 0 and the next digit is a 4, you just type 23,618, right? And so the answer is supposed to be in kilometers. So that